In this lecture, I'd like to talk about how we can read text from a file. For now, we're going to concentrate on reading text files. So if we want to read characters from a text file, we're going to use a couple functions. First one is going to be fgets. This will read a character from a text file that has been opened for reading. Remember, we always have to open up the file before we can perform any file operations on it, unless it's a rename or a delete. And then the file it cannot be opened. But if we want to do reading and writing or appending, we have to open that file. We know that we can open up files with different modes. In this case, for reading, we'd have to open up with an R or an R+, and then we can start calling fgets. The fgets function takes the file pointer as its only argument, and it will return the character read as type int. So here in an example, we create an mchar type int, and we say fgets pfile. It's going to read a character into the mchar variable with pfile as a file pointer. All right, think of pfile already been opened, return to file pointer. The mchar is of type int because EOF, which is our special character, our end of file, that's returned if the end of file has been reached. So we can always check that integer to see if it's EOF, and if it is, we don't want to read anymore. We don't want to call fgets anymore. The function fgets, which is equivalent to fgets, is also available. So gets is almost the same as fgets. You just want to use fgets. I think it has some more protection in it. With gets, it requires an argument of type file star and returns the character read as type int. It's virtually identical to fgets. The only difference between them is that gets may be implemented as a macro, and we don't even know what a macro is now. So we're going to stick with using fgets as our function to reading characters. You can read the contents of a file, again, when necessary. You can use this rewind function, which positions the file that is specified by the file pointer to the beginning of the file. So you can use rewind if you want to read again. Just say rewind and then the file pointer. Pretty basic. So here's an example. You have to include the standard IO header whenever we do any file operations. In our main function, we're going to create our file pointer. Probably want to initialize this to null, and we're going to create an integer. First thing we're going to do is we're going to open up the file using the fopen call, and we're going to specify the name of the file, and we're going to specify that it's for reading. That will return our file pointer. So now our fp pointer is pointing to a valid file. If it was unable to open file.txt, it's not in the right path or whatever, it's going to return null. So you want to check for null, make sure fp is not null. If it is null, exit the program. Otherwise, when you usually read characters, you're going to have them inside of a loop. So here we're saying while c equals fgets fp. This is reading a character from our file, passing in the file pointer to fgets, which returns an integer. Remember, we can jump out of the loop if that integer returned is the end of the file, because we don't want to read past the end of the file. Otherwise, we can just print out our character using %c and c. Last thing we want to do is we want to close the file. We then want to set our file pointer to null, and we can return. Let's try utilizing this, creating this inside of code blocks. So here's our program inside code blocks. It does exactly what it says. This program's not going to work unless we have a file on disk wherever the program's running. So first, if we build this, it should build okay. You should create an executable somewhere on your hard drive. I've been putting all of my projects inside my downloads directory. So if I go to my downloads directory and I go to the project name, which this is just a test project. So wherever you're storing your projects, mine's in test. If I go to test, you'll see that inside the bin directory, inside debug is your executable. Here is where you create your file if you had a relative path. So here I could just create a new file, and we could have it as a text file, so I can just create it as a text document, and it has to be named file. And then I'm going to put some information in it. I'm just going to put in some data such as hi, this is JSON, line feed, okay, nope, so forth, and I'm going to save it. This file has to exist in order for this program to work. So I created the file. Now when I run it, hopefully it will read what I just added to it and print it out. It says error in file, opening file, no such file directory, and that's probably because I have it in the debug folder, and this is not running in debug. So let's try running it in debug, and I think it would probably work now. We can say debug start. This will look for the executable in the debug directory, hopefully. We want to make sure it's run. Still not there, so you have to make sure you know where the executable is. Let's try somewhere else. Or better yet, I could just run the executable inside the debug directory, and it should find it there. So if I double click here, it actually doesn't pause. It just jumps out. So what you can do for that is, instead of returning, you can say system pause, I think it is, and it won't exit the program until you've run it. So let's now try it. So now it paused. It didn't execute the program. And what you saw was, hi, this is Jason. It was able to find the file, print it out okay, print it out nope, and then it paused. Otherwise, when you execute the program, it prints the data so fast and exits the program that you're done. So that's how one way you can test it. Not sure where it must be stored where the executable is stored, where it's running from. It must be running from somewhere else in your project directory. I'm not sure where it's running from. We might have to we could try moving the file to where the source code is. It might be running it from here. So here, we'll put it in here, and now we'll try running it from the ID, and maybe it will work. We don't build, we run it, and it was able to find it. So it looks like we have to put the file inside of where the source code is. So as long as we put that text inside the project file, it will be able to see it. So quick example of how you can open up a file and read single characters. Not the most efficient way to read from a file, because usually you want to read strings. But this will open it up. You see the fopen call, and you notice the while loop. That's important. Let's go back and talk about how we can read strings from a file, which is much more efficient. So that's reading a single character. How about reading a string? You can use the fgets function to read from any file or stream. This will read a string. It takes a character string as the first parameter, the number of characters you want to read, and then the actual file pointer. So this function is going to read a string in the memory area pointed by the stir. So you have to actually pass in the buffer where the data is going to be stored. And that's a pointer, so you'd have to allocate memory for it. And then it's going to read from the file specified as the third parameter, which is the file pointer. And then the end chars is going to say how much data to read. So if you put end chars as like 10, it's going to read in 10 characters unless it hits a line feed first. So it's going to either read an entire line, or it's going to read the number of characters that you specify in the second parameter. The end of line is specified by the \n, that whichever occurs first. If a new line character is read, it's retained in the string, and a null terminator will be appended to the end of the string. So if you actually specified more characters, it would read up to the line feed and then jump out. And then it gets that new line character and puts a null character at the end of it. If there's no error, fgets is going to return the pointer, which is the first parameter. It's going to return a pointer which gets returned from the function, and then it's also going to populate the stir pointer as the first parameter. If there is an error, null is returned, and then reading the end of file causes null to be returned. That means you read all of your strings. So let's look at an example. Here we have our main, and we're creating our file pointer, creating a character string. Here this is a pointer. We didn't allocate any data for it. We just create a character array. We opened up the file for reading only because it's R. We said if it's null, jump out. Otherwise, we just say fgets. We read in 60 characters, or if the line feed is before that, a line feed will come up, and then it will print it out in what's ever in the stir buffer. So stir is that first character that's passed in. And then we close the file pointer, set it to null, and return 0. So let's again take a look at this inside of our code blocks IDE. So the only thing that's changed in this program is really lines 14 to 17. We're using fgets to read our string in, and then we have a stir buffer. So we've also need to create a character array up here, which is our stir. And we want this to contain 60. We're reading in 60. We'll add a line feed, so it's going to read in 59 and then add a line feed to the end of it. So we could say 61. And then the fgets is going to be in an if statement, and it's going to read in each string until it either hits 60 characters or a new line, and it's going to print out that string. You'll notice that's not a while loop, so we're not reading to the end of the file. We read the end of the file, we get a null. So if we build this, we want to make sure we have our quotes correctly. Whenever you copy from PowerPoint, it messes up the quotes. And we want to make sure we created our variable C is not used. That's okay. So let's go ahead and run this. And you see, hi, this is Jason. So actually read in an entire line of text from the file. It read in the first line. So you would call it again and read in the second line. If you change the number of bytes read, say we just want to read 10, it would read in 10, and then it would return those 10 as opposed to reading the entire line. So here we just have it, hi, this I. So it's going to read in number of characters, your second parameter, or until it gets a line feed. And it stores that in str. str is a character array. We print it out. fgets. fgets is a lot more efficient for reading because we're not reading a character in at a time. We're reading in more data. Reading a character in a time is not as efficient. So now we know how to read in single characters. We know how to read in strings until they read a new line or a number of characters. But you can also read in formatted input from a file. So we have getC, fgetC, fgets, and now we have another function called fscanf. This is formatted input. Formatted input is data specified by, like, has a delimiter or has specific format associated with it. This fscanf function takes a file pointer stream and then a format. The format is just like the printf format specifiers that you use. So if you want to read in integers or doubles, you can specify data inside the file that are integers and doubles, and it will read that until it sees, like just like the scanf, until it sees a white space character. So the first argument to the fscanf function is a pointer to a file object that identifies the stream. We have to know what file we're reading from. The second argument to the function is the format. This is a C string that contains one or more of the following items: white space character, non-white space character, format specifiers. The usage is the same as the scanf and the printf, but instead it's from a file. So inside the double quotes, you can put in text. You can put in white space or non-white space characters, but the format specifiers are really is how you're going to store the data, how you're going to read in the data. And then you specify variables that you want to read it into. So the function returns the number of input items successfully matched and assigned. So here's what it looks like. You'll notice that the main is creating 3 character arrays, stir1, stir2, and stir3, just 10 bytes each. We create an integer called year. We create a file pointer. The first thing we do when we open up the file, in this case we're opening it up for reading and writing, but we're not going to actually write anything to it. We're just going to display what we're reading from it. We check to make sure the file pointer is not equal to null, and then here we're actually putting something in the file, fputS. We haven't talked about that yet, but this is writing something. Focus here on the fscanf. The fscanf is going to read in formatted data. And so what it's going to do is it's going to read in 3 strings separated by spaces. And so you see the %s space, %s space, %s space, %d. Then we're saying where we're going to read them into. Our 3 characters array and then our year. And we have to specify the address operator for our year. But the data is formatted a specific way when it's written. And when you read in something that's formatted, you have to understand the format of the file, how it's written. Here we know that the file is written by separating strings by white space. Right? So that's how we're going to read it in. And so we can read it in with one call, fscanf. We can use our format specifiers as our second argument, and then variable number of arguments for each, separate of each comma, to specify the data we want to read it into.